Hi everyone, I'm Sunja, Magazine MVP. Today we come to Azure Security Center video number 17. Understand application security. Who am I? I am Sunja. You can find me at my Twitter, and you can find more Azure Security Center hands-on lab at techconnect.io. Let's get started with the topic. Enterprise developer and software as a service provider can develop commercial cloud service or online business application that can be integrated with Azure AD to provide secure sign-in authorization for their services. To integrate an application or service with Azure AD, a developer must first register the application with Azure AD. Web app for container provide a flexible way to use Docker image. Application Insight is an extensible application performance monitoring service for web developers on multiple platforms. You use it to monitor your live web application, and it will automatically detect performance anomaly. Application Insight include powerful analytics tools to help you diagnose issues and understand what users actually do with your app. It's designed to help you continuously improve performance and usability. Application Insight works for apps on a wide variety of development platforms. Application Insight integrates with your DevOps process and has connection points to a variety of development tools. It can monitor and analyze telemetry from mobile apps by integrating with Microsoft Visual Studio App Center. After you install a small instrumentation package in your application and set up an application Insight resources in the Azure portal, the instrumentation monitors your app and sends telemetry data to the portal. In addition, you can pull in telemetry from the host environment such as performance counter, Azure Diagnostic, or Docker log. You can also set up web tasks that periodically send synthetic requests to your web service. All these telemetry streams are integrated in the Azure portal where you can apply powerful analytics and shape tools to the raw data. The impact on your app performance is very small. Tracking calls are non-blocking and are batched and set in a separate thread. API management help organizations unlock the potential of their data and services by publishing API to external partners and internal developers. Businesses everywhere are looking to extend their operation as a digital performance by creating new channels, finding new customers, and driving deeper engagement with existing ones. API management provide the core competency to ensure a successful API program through the developer engagement, business insight, analytics, security, and protection. You can use APIM as well as API management to tag any backend and launch full-fledged API program based on it. To use APIM administrator, create API. Each API consists of one or more operations and can be added to one or more products. To use an API, a developer subscribes to a product that contains the API and then call the API operation subject any user's policy might be affected. Let me check something. Okay, let's get back. Common scenario includes securing mobile infrastructure by getting access with API key, preventing DDoS by using trolling, or using advanced security policy like JSON web token validation, enabling independent software vendor partner ecosystem by offering fast partner onboarding through the developer portal, and building an API facade to decouple from internal implementation that are not ready for partner consumption, and running an internal API program by offering centralized location for the organization to communicate on a secure channel between the API gateway and the backend about availability and latest change to API and getting access based on organization account. Start with API gateway, which accept API call and route them to the backend. Verify API key, JWT token, certificate and other credentials and force usage quota and rate limit. Transform your API on the fly without code modification. Test backend response where set up. And not call metadata for analytic purpose. Package API into product setup policies such as quota or transforming on the API. Get insight from analytics and manage user. Conclude your overview with the dual portal which serves as the main web presence for developer. From here, they can read API documentation, try out an API via the interactive console, create an account, and subscribe to get API and access analytics their own users. Note that certificate can be signed by other trust certificate, or they can be self-signed. A self-signed certificate is signed by its own creator, therefore it is not trust by default. Most browsers can ignore this problem, however you should only use self-signed certificate when developing and testing your cloud services. The Microsoft Security Development Lifecycle. SDR introduces security and privacy consideration through all phases of the development process. It helps developers build highly secure software, address security compliance requirements, and reduce development costs. The guided best practice tools and processes in the SDR practice are used internally at Microsoft to build more secure products and services. Described briefly here, I will explain more about each item, each development process. Provide training. Security is everyone's job. Developer, service engineer, and program and project manager must understand security basics. They all must know how to build security into software and services to make product more secure, while still addressing business needs and delivering user value. Effective training will complement and reinforce security policy, SDR practice standard and requirement of software security, and be guided by insight derived through data or newly available technical capability. Although security is everyone's job, it is important to remember that not everyone needs to be security expert, nor strive to become a proficient penetration tester. However, ensuring everyone understands the ethical perspective, their goal, and the art of the possible will help capture the attention of everyone and raise the collective knowledge bar. Define security requirements. Considering security and privacy is a fundamental aspect of developing highly secure application and system. Regardless of development methodology being used, security requirements must be continually updated to reflect change in required functionality and change to the threat landscape. Obviously, the optimal time to define the security requirement is during the initial design and planning stage, as this allows development team to integrate security in a way that minimize disruption. Factors that influence security requirements include the legal and industry requirements, internal standard and coding practice, review of previous incidents, and known threats. These requirements should be tracked through either a work tracking system through telemetry derived from the engineering partner. Defining metric and compliance reporting. It is essential for an organization to define the minimum acceptable level of security quality and to hold engineering team accountable to meeting that criteria. Defining this expectation early help a team understand risk associated with a security issue, identify a fit security defect during development, and apply the standard throughout the entire project. Setting a meaningful security bar involves clearly defining the severity threshold of security vulnerability and never relaxing it after it had been set. Performing threat modeling. Threat modeling should be used in environments where there is a meaningful security risk. As a practice, it allows development teams to consider, document, and discuss the security implication of design in the context of their planned operational environment, and in a structured fashion. Applying a structured approach to threat scenario help a team more effective and less expensively identify security vulnerability, determine risk from those threats, and then make security fixes selection and establish appropriate mitigation. You can apply threat modeling at the component, application, or system level. Establishing design requirement. The SDL is typically true of as assured activity that help engineers implement more secure features, meaning the features are well engineered with respect to security. To achieve this, engineers typically rely on security features such as cryptography, authentication, and logging. In many cases, selecting or implementing security features has proven to be so complicated that design or implementation choices are likely to result vulnerability. Therefore, it is crucial that they are applied consistently and with a consistent understanding of the protection they provide. Defining and using cryptography standards. With the rise of mobile and cloud computing, it is important to ensure all data, including security, sensitivity, information and management and control data, is protected from unintended disclosure or alteration when it is being transmitted or stored. Encryption is typically used to achieve, however, making an incorrect choice when using any aspect of cryptography can be catastrophic. Therefore, it's best to develop clear encryption standards that provide specific on every element of the encryption implementation. Managing security from using third-party components. The vast majority software projects today are built using third-party components. When selecting which third-party component to use, it's important to understand the impact that a security vulnerability in them could have to the security of the larger system into which they are integrated. Having an accurate inventory of these components and a plan to respond when vulnerabilities are discovered will go a long way toward mitigating the risk. However, you should also consider additional validation depending on your organization's risk expertise, the type of component being used, and potential impact of a security vulnerability. Using approved tools. Define and publish lists of approved tools and their associated security checks such as compiler, linker, option, and warning. Engineers should strive to use the latest version of approved tools, such as compiler version, and to utilize new security analysis functionality and protection. Performing static analysis security testing (SAST). Analyzing source code prior to compilation provides a highly scalable method of security code review and help ensure that secure coding policies are being followed. Static analysis security testing (SAST) is typically integrated into the commit pipeline to identify vulnerabilities each time the software is built and or packaged. However, some offerings integrate into the developer environment to spot certain flaws such as assistant or unsafe or other brand function, and then replace those with safer alternative while the developer is actively coding. There is no one-size-fits-all solution. Development teams should decide the optimal frequency for performing SAST and consider deploying multiple tactics to balance productivity with added security coverage. Performing dynamic analysis security testing. Performing runtime verification of your fully compiled or packaged software track functionality that's only apparent when all components are integrated and run. This is typically achieved using a tool, a suite of pre-built attacks or tools that specifically monitor application behavior for memory corruption under previous issue and other critical security problems. Similar to SAST, there is no one-size-fits-all solution, and while some tools such as web app scanning tools can be more readily integrated into CI/CD pipeline, other dynamic application security testing such as fusing require a different approach. Performing penetration testing. Penetration testing is a security analysis of a software system performed by skilled security professionals simulating the action of a hacker. The objective of a penetration test is to uncover potential vulnerability resulting from coding errors, system configuration fault, or other operational deployment weakness. By doing this, the test typically find the broadcast variety of vulnerability. Penetration tests are often performed in conjunction with automated and manual code review to provide greater level of analysis that would ordinarily be possible. Preparing an incident response plan is crucial for helping to address new threats that can emerge over time. It should be created in coordination with your organization's dedicated product security incident response team. The plan should include who can contact in case of security emergency and establish the protocol for security servicing, including plan for code inherited from other groups within the organization and for third-party code. The incident response plan should be tested before it needed. That's all for today's video 17, Azure Security Center video 17. If you got any question about application security, you can find me at my Twitter, and for today's blog, you can find at dev.to/jackson. That's all for today. Thank you.